A vast network of curious orbiting celestial bodies, the solar system is immense in size. To better grasp its concepts and key players, let's scale it down to the size of Earth's atmosphere, piloting some of the world's most iconic aircrafts to demonstrate the system. For our first planet, Mercury, the planet with the quickest rotation around the Sun, we have the H-1 Racer, the fastest land plane of its time, flying at a max speed of 352 miles per hour. With an unpainted aluminum fuselage, reminiscent of the slate gray appearance of Mercury, the distance of 0.4 astronomical units becomes an altitude of 1,000 feet. The planetary diameter of 4,880 kilometers becomes 2 meters in the circular motion blur of the propeller. With this comparison, we produce a distance scale of 1 astronomical unit to 2,500 feet and a size scale of 2,440 kilometers to 1 meter. I chose this as if we had used a scale of size consistent to a scale of distance, many of our propellers would be smaller than 2 feet. The second planet from the Sun, Venus, will have the Douglas DC-3 at 1,750 feet from 0.7 astronomical units. Venus is quite similar in size to Earth, much as how the Douglas DC-3 appears similar to the Lockheed Super Electra. From a planetary diameter of 12,104 kilometers, the DC-3 will have a propeller diameter of 4.96 meters. However, this is produced by scale. The real Douglas DC-3 has a diameter of 3.51 meters. Earth, the only planet sustaining life, will be represented by the L-14 Super Electra. Being synonymous with its record-breaking achievements in commercial aviation presented for the 1939 New York World's Fair, the Super Electra is a fitting symbol for the values of life on Earth. From 1 astronomical unit, the Super Electra will fly at 2,500 feet. With a planetary diameter of 12,756 kilometers, its propeller will have a diameter of 5.23 meters. In reality, the Super Electras have a diameter of 1.79 meters. Our next planet is Mars, represented by the Ford Trimotor at 3,750 feet, scaled from 1.5 astronomical units. Much like our first attempts of planetary exploration with the rovers on Mars, the Trimotor was a pioneer of commercial aviation. In its experimental quality, the Trimotor was well known for its extreme turbulence and foul smells of motor oil in flight. Its challenges with airflow and interior stuffiness are reminiscent of the thin atmosphere on Mars. As the name suggests, the Ford Trimotor employed 3 propellers. The center propeller can be represented by Mars itself, a planetary diameter of 6,779 kilometers converted to 2.78 meters. The 2 peripheral propellers can be Mars's 2 moons, Deimos and Phobos. Deimos has a diameter of 12 kilometers, its propeller being 0.005 meters, or 5 millimeters, and the larger Phobos with a diameter of 14 kilometers being 6 millimeters. In reality, the Ford Trimotor's propellers had a consistent diameter of 2.46 meters. As the 5th planet from the Sun, and the first outer planet, the gas giant Jupiter will be represented by a giant of the aviation world. The H-4 Hercules, the largest flying boat ever made, was created in 1947 and held the title of the largest plane until 2019. Its impressive 8 motors can be comparable to the some 80 to 92 moons of Jupiter. From a distance of 5.2 astronomical units, the Hercules will fly at 13,000 feet. From a planetary diameter of 142,984 kilometers, the Hercules' propeller will have a diameter of 58.6 meters. In reality, the H-4 Hercules' propellers had a diameter of 5.23 meters. Saturn, the 6th planet, will be represented by the Lockheed constellation. Although as a commercial plane, many companies bought the Constellation or Connie models for their accolades in convenient travel, the most famous and synonymous association of this model is with those of Trans-World Airlines, or TWA, who adorned their Connies with the classic 2-stripe red painting every TWA plane displayed. Therefore, much like the vibrant Saturn, the constellation proudly wore its own rings. From 9.5 astronomical units, the constellation will fly at 23,750 feet. With a planetary diameter of 116,500 kilometers, the Connie's propellers will have a diameter of 47.75 meters. In reality, the Connie's propellers have a diameter of 4.57 meters. Next, for Uranus at 19.8 astronomical units, we have the Corsair at 49,500 feet. Uranus is a cold, icy giant. Corsairs are known for their Operation Freeze flights during World War II, in which bored soldiers in secret flew these planes high enough to cool an ammunition box full of milk to make ice cream for their crew. Unlike most planets, Uranus rotates on its side over a horizontal axis. The Corsairs were infamous for their left wing stalls, which would jerk their planes onto the sides. On the Corsair's propeller, the planetary diameter of 51,118 kilometers becomes 20.95 meters. In reality, Corsair propellers have a diameter of 4.27 meters. Neptune, the eighth planet, will be represented by the Sikorsky S-43. Neptune, alongside its 14 moons, is named after various mythological gods and spirits of the water, much as how, as a flying boat, the S-43 is associated with water. From a distance of 30 astronomical units, the Sikorsky S-43 will fly at an altitude of 75,000 feet. With a planetary diameter of 49,500 kilometers, the propeller of the S-43 will have a diameter of 20.29 meters. In reality, the S-43's propellers have a diameter of 4.88 meters. Far from the other planets, drifting in a slow orbit, the dwarf planet Pluto lies. Represented by the Wright Flyer, 39 astronomical units to an altitude of 97,500 feet, the distant quality of a dwarf planet is comparable to the glider of wood and fabric that would inspire the sturdy metal structures that would follow in years to come. With a planetary diameter of 2,370 kilometers, the propeller of the Wright Flyer will have a diameter of 0.97 meters. In reality, the Flyer's propeller had a diameter of 2.6 meters. Besides the planets, masses of asteroids orbit the Sun. Between Mars and Jupiter, the asteroid belt lies, containing around 1 million asteroids. Such a cacophony will be represented by the small dogfighting planes of World War I. Although asteroids in this belt rarely collide, although collisions do occur, the quantity and relative proximity or association with one another provides a relationship similar to the planes of World War I. Beginning at around 2.2 astronomical units, these planes will fly at 5,500 feet. Another belt of asteroids lies beyond the outer planets at around 50 astronomical units. Here, the icy fragments of the Kuiper belt, at such a far distance, are represented by the imagination and fantasies of what flight would ever be like for humans. These archaic dreams fly at an altitude of around 125,000 feet.